A comparative study of reversible and irreversible disease systems, using the viscoplastic energy and topology framework, number 1379, VMT Sharp 719, TDA Sharp 003, October 6, 2025. Gerald C. EclaireMD Foundation. Category: Computational Medicine and Systems Health. Mission Statement: I write these medical papers not for fame or recognition, since I have already lived a long and successful life, though not always a healthy one. My purpose now is to share what I have learned about health, disease, and medicine, so that others can better understand their own conditions, prevent illness, and live longer, healthier lives. Preface: This article is a personalized summary and reflection on my previous two papers, number 1377 on stroke and number 1378 on cancer. I have integrated several key ideas, including persistent homology, reversibility, and the deep review, beyond surface biomarkers, to connect these studies into a unified framework, under both Viscoplastic Medicine Theory, VMT, and Topological Data Analysis, TDA, my key observations and reflections. After completing these two papers, I reviewed them together and realized how complementary they are. Both studies apply VMT, from physics, and TDA, from mathematics, to the same long-term personal dataset, over 16 years, from 2010 to 2025. Yet, they describe two distinct medical realities: stroke as an organ level, partly reversible condition, and cancer as a cellular level, largely irreversible process. Understanding TDA in simple terms, I use topological data analysis, TDA, to uncover the hidden structure of my health data, going beyond numerical biomarkers, to reveal how variables connect and evolve over time. 1. Point cloud: each year's health record becomes a point in a multidimensional space. Together, these points form a geometric cloud that reflects my body's changing condition. 2. Distance and metric: the closer 2 points are, the more similar those years were. I use the straight line, Euclidean, distance to quantify change. 3. Via torus Rips complex: small circles are drawn around each point. Overlapping circles connect points, forming lines and triangles, a skeleton of relationships among data. 4. Homology: 0D, 1D, 2D, 0D identifies separate clusters, isolated health phases. 1D finds loops, repeating cycles. 2D detects cavities, missing or skipped physiological states. 5. Persistent homology: this shows how clusters, or loops appear and merge as the distance threshold grows. When all points finally connect into one cluster, it means my system has stabilized, as it did after 2015. 6. Persistence diagram: barcode: each bar represents a pattern. Longer bars indicate lasting changes, short bars show temporary noise. My longest bar marked my recovery and stabilization phase. 7. TDA contraction: over time, my scattered points moved closer together, meaning my internal systems became more coordinated, from chaos to harmony. 8. Manifold: the overall geometric surface formed by all points, showing how my health variables began acting together as one unified system. In short, TDA allows me to visualize the geometric shape and internal structure of my health system, rather than just its laboratory values. Stroke versus cancer, reversible versus irreversible. In my stroke study, the main issue was organ-level damage, blood vessel walls becoming calcified, stiff, and prone to blockage or rupture. With strict lifestyle control and stable glucose, blood pressure, sleep, and stress management, this kind of damage can be partly reversible. My VMT model showed a 97% reduction in vascular stress energy, matching the TDA finding that my health geometry became more cohesive and stable after 2015. By contrast, cancer operates at the cellular level, involving genetic mutations and abnormal growth. Once a cell mutates, the process becomes largely irreversible. What lifestyle management can influence is not the mutated cells themselves, but the metabolic environment that either feeds or suppresses their progression. My VMT and TDA results for cancer show that by 2015, my internal environment, glucose, visceral fat, diet, exercise, sleep and stress, had stabilized, reducing the chance for new mutations to advance. In summary, stroke affects organs and can be partially repaired, while cancer originates within cells and can only be controlled through long-term stability of the body's metabolic and energy state. My lifestyle improvement appears to have a greater impact on reducing stroke risk than on cancer risk. Looking beyond surface biomarkers, clinicians typically focus on surface-level biomarkers such as data of glucose, blood pressure, or cholesterol. I look deeper, beneath those numerical numbers. Through VMT, I examine the hidden interaction energy between the disease process and its multiple stressors. How strain builds, transfers, and dissipates within the body. Through TDA, I observe how the geometric shape and connectivity of the data change. How yearly variables link together to form a more coherent, lower stress structure. Together, these two approaches reveal both the magnitude of internal stress, VMT, and the organization of systemic stability, TDA, understanding TDA contraction. In both the stroke and cancer studies, I describe a TDA contraction, the gradual tightening of my health data points over time. From 2010 to 2012, my data were widely scattered, showing instability as blood pressure, glucose, and weight behaved independently. From 2013 to 2015, these points began clustering, meaning my biological systems started working together again. By 2015, the entire data cloud became compact and round, like a smooth sphere. Healthy, instead of a jagged polygon, unhealthy. This mathematical and physical transformation shows that my health system had stabilized, and that relationships among variables became predictable. In plain terms, my body moved from chaos to coordination, from disorder to harmony, from unhealthy to healthy. The cancer study, simplified explanation. In the cancer paper, I analyzed 5 major lifestyle and metabolic factors: obesity, diabetes, health, age, diet, and daily activity, steps and sleep, in a 5-dimensional space. In early years, my data looked like scattered islands, with each factor pulling in its own direction. When viewed together, the shape resembled a jagged, multi-angled polygon, a reflection of internal disorder. After lifestyle improvement, these islands merged into a single, smooth landmass, symbolizing a balanced internal environment, like a perfect sphere or ball. I call this transformation metabolic reorganization. When the body's systems begin to synchronize into one stable and harmonious pattern. Why I use the Vietoris-Rips complex and 0D homology. The Vietoris-Rips complex builds a geometric skeleton. By connecting nearby data points, I chose it for its simplicity and accuracy in small datasets. Using 0D homology helps detect major transitions. When my health shifted from fragmentation to unity. In the future, I plan to explore 1D loops and 2D cavities to detect repeating or missing patterns, such as seasonal glucose changes or blood pressure oscillations. In simple words, 0D homology helps me identify when my health data came together, while higher order homologies might show whether it ever went in circles or opened gaps again. These will be my future research challenges, as I continue uncovering deeper insights into long-term body dynamics. Overall reflection. When viewed together, the VMT and TDA models do not just measure data. They describe how life reorganizes itself. VMT shows how the body releases stored internal energy through stress-strain interactions, like a metal returning to its shape after deformation. TDA reveals how the body restores order and structure, like puzzle pieces forming a complete picture. In stroke, I watched my blood vessels regain partial elasticity. A story of physical recovery. In cancer, I observed my metabolism regain internal order, a story of cell systemic stabilization. Both journeys began in chaos, from 2010 to 2012, transitioned to recovery, from 2013 to 2015, and reached stability, from 2016 to 2025. These patterns of geometric cohesion, energy reduction, and variable harmony represent more than health improvement. They show that the human system can relearn equilibrium when guided by knowledge, discipline, and self-awareness. All of this can be achieved through the basic principles of mathematics and physics, applied with pathophysiology, knowledge, willpower, patience, curiosity, and precision. Disclaimer: this content is for educational reference only, and not medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be edited or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.